स्टूडेंट्स, आई एम शिवा सर फ्रॉम साईनगर देहरादून। लास्ट क्लास में हमने देखा था एक्सरसाइज 1.2 ऑफ सीबीएसई क्लास 9। तो अभी हम लोग नया टॉपिक स्टार्ट करेंगे, डेसिमल एक्सपेंशन ऑफ रैशनल नंबर्स। तो आपको पता ही है रैशनल नंबर्स मीन्स इट इज डिनोटेड एज पी अपॉन क्यू वेयर क्यू इज नॉट इक्वल टू 0 एंड दिस जो फ्रैक्शन वाले फॉर्म में हम लोग लिखते हैं इसको अभी हम लोग डेसिमल फॉर्म में कन्वर्ट करेंगे और ये बिल्कुल सिंपल है। फॉर एग्जाम्पल अगर हमने 7/8 लिया तो 7 को आपको 8 से डिवाइड करना है जब तक उसका डिवीजन कंप्लीट होता नहीं है। तो अगर हमने डिवीजन स्टार्ट कर दिया तो सबसे फर्स्ट तो 0 आएगा यहाँ पर। जब हम यहाँ फर्स्ट 0 लेंगे तब यहाँ पॉइंट डालते हैं। नाउ 8 8s are 64, you will get the remainder as 6. Then 8 7s are 56, you will get the remainder as 4. Then 8 5s are 40. Now the division is complete with remainder 0. So 7/8 can be expressed in the form of 0.875. Similarly, if we take another example, suppose we take another example 10/3. Now if I divide this 10 by 3, 3 3s are 9, 1 is the remainder, again 0 comes, we take point, 3 3s are 9, again 1 comes, 3 3s are 9, again 1 comes, and this goes on and on. It is non-ending. Therefore, there are two types of divisions where this here remainder becomes 0, but here remainder does not become 0. Some set of numbers goes on repeating in the quotient. See here 3 is the single digit which is going on repeating. यहाँ पर point के बाद 3 जो है बार बार repeat हो रहा है, तो हम इसको बोलते हैं non terminating, means ये खत्म नहीं होने वाला division है, which is called as non terminating and recurring मतलब बार बार रिपीट होने वाले डिजिट्स है। इसको हम आंसर में लिखते समय ऐसे भी लिख सकते हैं 3 पॉइंट, जितने डिजिट्स रिपीट हो रहे हैं उसके ऊपर पॉइंट डालिए, या एक से ज्यादा होगा तो उसके ऊपर ऐसे लाइन खींचा जाता है जितने डिजिट्स होते हैं वो, और वो ये दिखाता है कि ये डिजिट्स आपके बार बार रिपीट हो रहे हैं। यहाँ पर आपका टर्मिनेट हो रहा है, यहाँ पर डिवीजन जो है आपका टर्मिनेट हो रहा है, सो वी विल कॉल इट एज टर्मिनेटिंग एंड नॉन रिकरिंग। हियर इट इज नॉन रिकरिंग। एक्चुअली टर्मिनेटिंग विल नेवर बी गिवन एज रिकरिंग और नॉन रिकरिंग, बट नॉन टर्मिनेटिंग रिकरिंग भी हो सकते हैं, नॉन रिकरिंग भी हो सकता है। तो ये टाइप के जो डिविजन्स है, ये दो टाइप के जो डिविजन्स है, ये हम लोग एक्सरसाइज 1.3 में अभी हम लोग देखने वाले हैं। ओके, तो एक्सरसाइज 1.3 का सबसे फर्स्ट क्वेश्चन वही है, राइट द फॉलोइंग इन decimal expansion and say what kind of decimal expansion each has. Then the first question is 36/100. Now this 36/100, you know it can be written as 0.36. What is this? It is terminating. सेकेंड वन इज 1/11। 1 को डिवाइड करके देखिए 11 से, again 1 comes and again we will start with, so 0909 is goes on repeating and it is non-ending. Therefore we can write as 0.09. This digit is repeating and hence it is non-terminating recurring. Understood? Same way, third question is 4/1/8. If I will convert this into proper fraction, it comes to be 33/8, and division of 33/8, when you do it, it is again terminating one. यहाँ पर कोई रिमाइंडर नहीं बच रहा है और यहाँ ये डिवीजन कंप्लीट हो जाता है, दिस इज टर्मिनेटिंग। नेक्स्ट इज 3/13. Now each division I am not going to do. See, in this 3/13, some number of digits go on repeating, means 2 3 0 7 6 9, again 2 3 0 7 6 9. So these digits are repeating, therefore while writing the answer we can write as 2 3 0 7 6 9 and a bar upon these number of digits, which means it is non-terminating and recurring. Understood? Next one is 2 upon 11. 2 upon 11, again on division you get 18 18 18, these sets of digits which are repeating, and therefore we will write a bar upon that, which is non-terminating recurring. Next one is 329 divided by 400, which is 0.8225, and the division is complete, therefore it is terminating. Understood this question? Now we will see the next question, which is second question. Second question is, you know that 1 upon 7 is 0.142857, which is again a bar. That means these number of digits are repeating again and again. Can you predict what the decimal expansions of 2 upon 7, 3 upon 7, 4 upon 7 and 5 upon 6 upon 7 without actually doing the long division? So what you have to do here is, you just have to multiply the digits, that is recurring digits 1 4 2 8 5 7 multiplied by 2, because here it is 2 into 1 upon 7. So 2 into 1 upon 7 will give you this answer. So answer will be 0.285714, and again you put a bar upon that. That means this, without actually dividing 2 by 7, we got the answer, because we knew 1 upon 7's answer, and therefore we got 0.285714 as the recurring expansion of 2 upon 7. Similarly here you will multiply by 3 and you will get 0.428571, which is again recurring. Then 4 into 0.571428 will be the answer. Here 5 into, and the answer will be 0.714285. Similarly for 6 upon 7, 6 into, you will get 0.857142. This is the recurring expansion of given decimal fractions. Understood? Third question is, express the following in the form of P upon Q. Now the given question is 0. Here you have been given the decimal expansion. So what is this number? This is actually x 0 point repetition of these numbers. We will take 3 times only and we will put dots. Now we will multiply both sides by 10. So what we will get is 10x is equal to, when you multiply this with 10, then your point will get shifted towards the next point, next one digit, because 1 0 is multiplied over here, 6.666, and repetition of those digits. Now what we are doing, this is equation 1, this is equation 2. Subtract 1 from 2. When you subtract 10x minus x, you will get 6.666 minus 0.666, which is equal to, x is equal to, 9x is equal to 6. X is equal to 6 upon 9, and you get the answer 2 upon 3. So what you have done is, you have expressed the decimal expansion in the form of rational number, that is in the form of P upon Q. Similarly, next question is 0.47. bar. So x is 0.474747 and repetition. So what we will do, we will multiply by 2 digits are repeating, therefore we will multiply by 10x. We will get 4.7, sorry, here it is only for 7 I think, therefore your repetition is for only 7. So 4.77777. Then again we will multiply by another 10, which will become 100x, 47.77777. Now what you will do is subtract these two equations. Subtract equation number 2 and equation number 3. Subtract 2 from 3. So 100x minus 10x is equal to 47.777 minus 44.777. What you will get is 43.000. That is 100x minus 10 is 90x. So x is equal to 43 upon 90. So this will be your answer. You have to see that after point there should be the same numbers, so that we can subtract it easily. So we have multiplied by another 10, so we get 100x, and 100x minus 10x, we get the answer as 43 upon 90. Next, third question is 0.001, which is x 0.001 and 0.001, 0.001 and so on. Now here number of digits are 3 which are repeating, so we will multiply by 100x, which will give you 1.001001. This is your second equation, your first equation. So subtract first from the second. So 100x minus x is equal to 1.001 minus 0.001, which will give you 1. 90x is equal to 1, x is equal to 1 upon 99. So x is equal to 1 upon 99. This is your answer. Next is the fourth question. Fourth question, express 0.9999 in the form of P upon Q. Are you surprised by the answer? With your teacher and classmates, discuss why the answer makes sense. Now x is equal to 0.9999. First equation. Now we will take 10x is equal to 9.9999. Second equation, subtract second from first from second. So we will get 10x minus x is equal to 9.9999, which will give you 9, and here also 9. So x value will become 9 upon 9, which is 1. So they have asked, are you surprised by this answer? So no, nothing to surprise about, because 0.9999 is equivalent to 1. It is very close to 1, and whenever you increase the second decimal, you know that the previous decimal also gets increases. So 0.999 is equivalent to 1. Understood? Next question is, what can be the maximum number of digits to be repeating in the block of digits in the decimal fraction expansion of 1 upon 17? Now what you have to do is divide 1 by 17, and the answer you are going to get for 1 upon 17 is equal to 0.05882352941176647. And again we are going to see that 117647 is going on repeating. So this number of digits, this is going on repeating. So entire number, which is this over here, will go on repeating, and this will be your total answer. Okay. The next question, sixth question is, look at the several examples of rational numbers in the form P upon Q, where P and Q are integers with no common factors other than 1 and having terminating decimal fractions. Can you guess what property Q must satisfy? So 2 upon 5, 0.4, 1 upon 10, it is 0.1, 3 upon 2, it is 1.5, and 7 upon 8 is 0.875. You can see that there are no common factors between these numerators and denominators. This is the same property which we had studied in the first fundamental theory in the first exercise. Write three numbers whose decimal expansions are non-terminating and non-recurring. You can take any examples. For example, 0.4141114111411114. So this is going on and non-terminating and non-recurring also. Other examples can be 201, 001, 0001 and so on, where there is no repetition of the remaining part. Answer of pi 31, 3.1416 and so on. This is non-terminating, non-recurring. Understood? Find three different irrational numbers between the two rational numbers 5 upon 7 and 9 upon 11. Now what is 5 upon 7 is given over here, 0.714285 recurring, and 9 upon 11 is 0.81 recurring. The examples can be between the 7 and 8, decimal 0.7 and 0.8. So we can take 72722, 7222 and so on. Second, we can take 0.73, 733, 7333 and so on. Other we can take as 0.74, 7444 and so on. So these are the examples to find the three different irrational numbers between two rational numbers. Next one is, classify the following numbers as rational or irrational numbers. So root of 23 does not exist, so it is irrational number. Root of 225 is 15 and therefore it is a rational number. 0.3796, this is the terminating one, decimal fraction, decimal expansion, that is why it is rational number. 7.478478 and so on, this is recurring, therefore it is a rational number. Now last example, 1.10, 100, 100, 1 4 times 0 and so on. This is non-terminating and non-recurring, that is why it is irrational number. Non-terminating and non-recurring will be irrational, remaining all will be rational numbers. So this was exercise 1.3. We have seen that how decimal expansion of rational number can be denoted. It is very easy. If you have liked the video, please subscribe it so that we can reach maximum number of students. Thank you.